Our next problem is that we are having a pressure vessel like this one. Our design pressure is 555 psi. We are having the inside diameter 58 inches and our nominal thickness or original thickness, or as in here indicated, our initial thickness is 1.125 inches. And our allowable stress, you know what's the allowable stress from the ASME section 8 division 1, is 20,000 psi. Our joint efficiency is 0.85, and you know that's probably, so our pressure vessel is spot radiography. We're talking about the shell. So is the spot radiography, and the spot radiography we get the joint efficiency 0.85. Corrosion allowance of 1/8 inch, and metal loss at a certain point on this pressure vessel away from the weld, not at the adjacent to the weld, far, almost here says 4 inch from the weld seam. 4 inch from the weld seam, somewhere in here, not close to the weld seam, is 3/16 inch. So we measured at that point. We are having the internal corrosion from the inside of the pressure vessel. When we put the probe at this point, we're having the initial thickness, and when we're calculating what we measured, we can calculate what's our metal loss in here. Our metal loss is 3/16 inch in here. The pressure vessel been in service for 10 years. No corrosion observed in a weld, so we made internal inspection. We went inside of the pressure vessel. We looked at all the surface inside of the pressure vessel, and we didn't see any corrosion on weld seams. So that's here indicated. And then the question is in here, is safe for operation with this condition? So we're going to solve this problem to see if we can operate this pressure vessel with this condition. First things you have to do, you have to calculate the minimum thickness. Minimum thickness is required to resist against the hoop stress. You remember that, circumferential stress. We had this from the section 8 division 1. So I'm writing the formula in here. You can see the 555 multiplied to the 29.125. If you remember, this is the ID. We have to put here radius, and we have to add the corrosion allowance to this. This is the subject of the ASME section 8 division 1, and you know why we are doing this. You can review back the ASME section 8 division 1. And we are putting here 20,000 psi, and instead of putting the 0.85, I am putting here 0.1. This is the kind of a concession that the API 510 gives us. In one of the clauses says if the corrosion patch or the area that's subjected to the corrosion is away from weld and by more than 1 inch or 2 times all the thickness, whichever is greater, then you can consider joint efficiency as a 1 if the joint efficiency is something less than 1. Because why we said spot radiography, we consider joint efficiency 0.85, and we put the 0.85 in here, we're getting the higher thickness because these are in a different side and different opposite relationship. You get the, you make here bigger, this is going to be smaller, or you make here less, they're going to get the bigger thickness in here. So that's why this 0.85 that we considered for a joint efficiency actually was because of the weld, not because of the a regular surface. So since the corrosion happened in the surface and not in the weld, we are going to consider that as a 1 to use these, we can say, whatever you can name it, a concession you can name it, a bonus that API 510 provided to us when there's a corrosion happening on the surface away from the weld seams. So we put the 1 in here instead of the 0.85 because corrosion didn't happen in the weld area, is away from the weld area. You can say it's 4 inch from the weld seam. And then this concession, and then what I said, this bonus is coming from the API 510 7.4.5 to use 1 instead of 0.85. Now we calculate in here, and minimum thickness, the product of this calculation is going to be 0.821 inches. This is the minimum thickness that we calculated for our shell. Now we are calculating the remaining thickness. You remember I said we made a measurement at the certain point, and which the nominal thickness, as you can see here, was 1.125. And we considered the question says to us that the metal loss was 3/16 inch. I need to calculate to see what's the remaining thickness at the corrosion area. And the remaining thickness, 1.125 minus 1.875, this is a same value of a 3/16 inch. So my remaining thickness at this point is 0.9375 inch. So my thickness at the corroded area, which is the internal corrosion I'm considering, and at this point is this value, and I calculated the minimum thickness is 0.821 inches. So my current thickness or actual thickness is greater than minimum thickness, so it is safe to work. And I use this concession that this gives me using the 1 comes from the API 510 clause number 7.4.5. Now consider for a moment that we didn't have this chance to use this clause, and what would have happened to us. So I'm going to go and make a different calculation in here, but before going to the calculation without considering this, let's calculate what's the remaining life in here. Remaining life based off the formula in the API 510 says T actual, the current thickness, which is this value, minus T minimum, which is this value, to the corrosion rate. This formula gives us the remaining life. So our remaining life, so we have to first calculate corrosion rate to be able to calculate the remaining life. The corrosion rate, you know, T actual minus minus the previous thickness, or the nominal thickness, or the T previous minus the current thickness, and then divided by the year between is going to give us the corrosion rate. So we in the first day, it's gone to the operation, our thickness was 1.125 inches minus 9375, which is the current thickness, actual thickness, and this happened in the 10 years. In the 10 years, the thickness from this gone to this. So my corrosion rate is 0.0187 inch per year. If I multiply this to the 1000, I'm going to get 18.75 mils per year, or MPY. So this about our corrosion rate. Now let's calculate the remaining life. We didn't have this, so we calculated this. Now T actual, this value today, minus T minimum, and you can see here 0.821, and divided by the corrosion rate that we calculated from here, we get the 6.23 years as remaining life. So it means this pressure vessel, actually, if there is a patch in here with this value, can be repaired by an insert patch, or might be considered by the pressure vessel engineers or the company that is owner and user to make some re-rating on this pressure vessel with the reducing the design pressure and other stuff. But by the way, if the design condition is the same things that indicated in here, this needs to be repaired or replaced in a 6.23 years. Now consider for a moment, we wouldn't have used this bonus, that's API 510 at the 7.45, gave us to use the joint efficiency 1 instead of 0.85. I'm going to calculate the same formula that we are having in here again with the joint efficiency 0.85. I'm considering we didn't have this concession or this bonus in here. You can see my minimum thickness is going to be 0.969 inch, and then our actual thickness, two-day thickness, the current actual thickness is not greater than minimum thickness. So this is not a safe operation. This should be immediately go to the rate off and shut down. And I calculated the remaining life with this condition. You can see my remaining life came negative. Our corrosion rate is going to be the same, and you can see my minimum thickness without this is the new value, and our actual thickness is the same, and I'm getting the minus 1.68 years, which is a negative value.